the 2013 relative velocity. So a lesson to have your phone on mute. Aircraft P, flying at 600 kilometers an hour, sets out to intercept Q, which is a distance away in a direction west 30 degrees south. Find the direction P should fly in to intercept Q. Okay, diagram's given. There is an easy way to do this question, which we'll look at the end, but let's do it the more regular way first. If we take another little diagram here, my eye, and we have P going down in this direction, we call this the angle A. So the velocity of P is flying at 600, and we can see it's going in a minus direction. So minus 600, and I is adjacent to the angle, and then minus 600 by the sine of A times J. The velocity of Q is equal to 600 positive I, 600 I plus 0 J. So the velocity of P relative to Q is equal to the velocity of P minus the velocity of Q. So we're going to have minus 600 cos A minus 600 times I. And then we're going to have, I'll put the plus inside, but it's a minus. It's a minus, isn't it? P minus Q, yeah, minus 600 sine A times J. Velocity of P relative to Q. Okay, let's just move back across here. If we look at the 30 degrees here, the tan of 30 is the J, the opposite, over the I, which is adjacent. So we can change this velocity vector here. We have the tan of 30 is going to be equal to the J over the I. Now they're all minuses, so we can change them all to pluses. 600 sine A over 600 cos A minus 600. Sorry, plus 600. So that's tan of 30 is 1 over root 3. 1 over root 3 is equal to 600 sine A over 600 cos A plus 600. So if we cross multiply and divide by 600, and we do one thing at a time, let's cross multiply first. Root 3 times 600 sine A is equal to 600 cos A plus 600. So that's going to be root 3 sine A is equal to cos A plus 1. I don't think there's any way to simplify this other than the replacement will work for cos squared A sine squared A. If we square both sides, might help. Root 3 sine A to be squared is equal to cos A plus 1 to be squared. The cos squares and sine squares normally will help us. So this will give us 3 sine squared A is equal to cos squared A plus cos A twice, 2 cos A plus 1. And look, I can definitely replace this sine squared with 1 minus cos squared. Let's just write that down. Sine squared A plus cos squared A is equal to 1. And we want to replace sine squared. So we're going to write 1 minus cos squared is equal to sine squared A. So 3 by 1 minus cos squared A is equal to cos squared A plus 2 cos A plus 1. 3 minus 3 cos squared A is equal to cos squared A plus 2 cos A plus 1. Long-winded version this. Okay, bring the two things across. We're going to get 4 cos squared A. We just have another constant there. we're going to have plus 2 cos A. And we're going to have a minus 2. 1 minus 3 equals naught. Now, we should be able to factorize that with our really good 3 scales. 2 cos A by 2 cos A, or 4 cos A by cos A. I think it's this one actually, 4 cos A by cos A. It has to be a 2 by 1, and we want a positive 2 cos A. So, nope, plus 2, not positive. Let me just change that. It's going to be 4 cos A. We're going to have a 1 here and a 2 here to give me a plus 4. Take away 2 gives me my plus 2 in the middle. So what would that leave us with? 4 cos A minus 2 is equal to naught, or 4 cos A is equal to 2. Cos A is equal to 2 over 4. Or cos A is equal to minus 1. Well, that's not going to help us. That's going to be 180 degrees. What direction will it be going in then? So it's definitely this one. The cos A is equal to a half. So A is equal to 60 degrees. Now, let's jump back up here. I wonder, did the exam setters realize what they were doing here? That's going to travel at 600 times t, and so is that one. So this angle is alternate to this angle here, so that's 30. And because we've two 600t's in the same triangle, this is an isosceles triangle where this one is 30. So this angle in here is 30 degrees. So you can see that P needs to set off at 30 plus 30, which is equal to 60 degrees. And what did we write down here? We wrote 30, we should have wrote 60. Oh, we did write 60. So that's the end of that question. Obviously there's a really quick way, but I think this method here, practice this method. These are the methods that are going to come up in the future.